What's up? I'm Vin, and I'm going to go through the June 2025 Algebra 1 Regents, and I'll leave a link to a copy of this test in the description below. Now let's get started. So first, we're going to go over the part 1 multiple choice questions. There's 24 questions here, and each one is worth 2 credits. Question 1, the expression 10 over square root 2 is equivalent to, and we have these 4 options to choose from. So for this one, I'm going to show how to do this the algebraic way first, and then I'll show how to use the calculator. So we have 10 over square root 2, and for this we are rationalizing the denominator because right now square root 2 is an irrational number. So if we focus down here, this number is irrational and we want to make it rational. So the way we do that is we multiply the bottom by square root 2. But with fractions, if you multiply the denominator by square root 2, you have to multiply the numerator by square root 2 as well. Okay, so we're just going to multiply by square root 2 over square root 2. And from here, what we have, we've got 10 times square root 2 is 10 square root 2. And for this one, if you just know that square root 2 times square root 2 is equal to 2, that helps you finish this question much faster. Okay, but if that doesn't make sense, then just know this rule for multiplying radicals. When you have square root a times square root b, this is equal to square root of a times b. And this rule works when a and b are both greater than or equal to 0. Okay, so we could use this when a and b are greater than or equal to 0. So if I want to show every little step here, what I could do is I could do square root of 2 times 2. And now from here, we have 10 square root 2 over the square root of 2 times 2 gives us the square root of 4. And now in the next line, we have 10 square root 2 over the square root of 4 is equal to 2. All right, but one nice thing to know is this idea over here. When I have something like square root a times square root a, this is just equal to a when a is greater than or equal to 0. Okay, this is just something here that we could use. So when I do these types of questions, I just simplify it fast. I go right from this step right to this step. And now I just combine the like terms here by division. So we have 10 divided by 2. So what we could do with this, we could say 10 divided by 2 is 5. So we have 5 square root 2. All right, please don't do 2 divided by 2 is 1 because you can't divide a number inside of a radical with a number outside of a radical. So we are only able to divide these terms here, and we get 5 square root 2. But here's another way to do this question. We could just go to the calculator, and we press alpha y equals enter to pull up a blank fraction, and we have 10 over the square root of 2. Okay, so we just type in the question, and then we could go through all of the answer choices. Well, we don't have to go through choices 1 and 2 because this number here, 7.071, is obviously not equal to 5 or 20. And then it's most obviously 3 because 5 times square root 2 is going to be a little bit more than 5. If I multiply 10 by a number that's greater than 1, that's going to be greater than 10, so 7 here is not possible. But let's just check. 5 square root 2, if I write this in and I'm pressing 5 second x squared to pull up the square root, and I have my 2 in there, and I press enter, see how I have matching decimals, so 3 is definitely correct. Question 2, a parabola is graphed on the set of axes below. Over which interval is the parabola only increasing? So if we're looking for where the parabola is only increasing, we want to know when is the parabola going up. So I'm immediately drawn to this part of the graph over here. So this section here is when the parabola is going up, so that's where the parabola is increasing. But now when you define the interval, you want to focus on the x values. So now I look at the graph here, and I'm just going to label the x-axis. We have 1, 2, 3, 4, 5, and so on. And notice that the graph here starts to go up in this space over here when x is equal to 3. And I'll change colors here. So in this space, this is the moment when the graph starts to go up. At x equals 3, technically the graph is neither increasing nor decreasing. This is the turning point, the vertex. But we can include it in the answer here. So we could say here from 3 to infinity. And now just know infinity never gets a bracket because infinity is not a number, it's only a direction. If infinity were the biggest number, then infinity plus 1 would be greater. So we can't contain infinity, that's why we use a parenthesis instead of a bracket. So choice 2 is our answer. Question 3, which scenario represents an exponential relationship? So when we're looking for an exponential relationship, we're looking for something that if we were to graph it, it either looks like this or it looks like this. And the equation for an exponential function is in the form of y equals, and we have a constant times some other constant to a variable x power or t power. So we're looking for something like this. Now, with these types of questions, what they usually do is they throw in something linear in the answer choices. So a linear function has a constant rate of change. So it has a constant, and I'll just write it out here once, rate of change. And when we're thinking about the actual equation, that would be something in the form of y equals mx plus b. And we would have the graph is either a line going up or a line going down. Usually, we can have vertical and horizontal lines, but these are the ones for real world scenarios that we're most likely looking at for a lot of the cases. So here, let's say choice 1. We have Kirsten's New Year's resolution is to lose 1 pound each week. Well, let's say I just draw this out on a graph. So Kirsten, I don't know, maybe Kirsten, we'll just say is, you know what, I'll make Kirsten's a grizzly bear. So she's 600 pounds and she wants to lose 1 pound each week. Now the graph only makes sense to go, well, even here is unrealistic. I mean, 0 pounds is just kind of insane. But I mean, whatever, we'll just put this here anyway. But each week that goes by, Kirsten loses 1 pound. Okay, so that's 1 week goes by, that's 599. And then 2 weeks goes by, that's 598. And you could see if we were to plot these points are forming a straight line. So this would not be an exponential relationship. This would be a linear relationship because there is a constant rate of change. Okay, so a constant rate of change here. If I had to actually write an equation for this, it would be something like y equals minus x and then plus 600, where x is the number of weeks. And you could see, you know, 1 week goes by, we subtract 1 pound. 2 weeks goes by, we subtract 2 pounds from 600 and so on. So this one here is out. But the key, you don't have to actually write the equation out, is the fact that it's 1 pound each week. That shouts constant rate of change, which is not exponential. Next, we have Sarah wants to increase her grade by 5 points each quarter. So this is once again a constant rate of change because the number of points each quarter she wants to go up by the same amount. Okay, so 2 is out. Tommy wants to reduce his spending by $50 each month. So once again, constant rate of change, $50 each month. And now finally 4 is the one that's different. And it has to be our answer because of process of elimination, but you see how it's different. Dylan hopes to grow his business by 5% each month. And if I had to actually write an equation out for this, let's say his business right now is worth $10,000. So the formula we would use is A equals P times 1 plus or minus, but he wants to grow his business. So plus R to the T power. And here R is equal to 5%, which is 5 out of 100, which is equal to 0.05. So if I plug all this in, let's say his business, the principal value, it's worth $10,000. Well, we put 10,000 here and then 1 plus 0.05 to the T power. And this would give us, we would have 10,000. Oh yeah, it should be 10,000. So 10,000 times 1.05 to the T power. And notice how it's matching this exponential form here. And if we were to graph this, it would look something like the first graph here. So choice 4 is definitely our answer. Question 4, the geometry test scores for Andrea and Joe are shown in the table below. And we want to know which statement about their scores is correct. So if we look at the answer choices, we have to find mean and standard deviation. So what I'm going to do is I'm going to find the mean and standard deviation for each of these one at a time here. So we go over to stats, edit, and I'm going to do Andrea's list and then Joe's list. So we have 82, and then we have 87, we have 90, and we have 84. And from here, we just press stats, calculate one variable statistics, and this will give us the average and the standard deviation for Andrea's values. So now that I have these important values here, I'm going to go on to Joe's list. So we have stats, edit, and now I'll type in Joe's list. We have 91, we have 78, we have 94, and 67. Okay, and for this one, we press stats, calculate one variable statistics, calculate, and we're going to borrow these values here. So now we look at each answer choice. Both the mean and standard deviation of Andrea's test scores are higher than Joe's. Well, the mean is this value over here. So the mean, so I'm just going to point out here, this one is the mean. And the standard deviation is this one here. Okay, and then we'll look at Joe's list. So we have the mean and we have the standard deviation. Well, this one here is not true because you could see that Andrea's average is higher, 85.75 versus 82.5, but Joe has a higher standard deviation. And just know a standard deviation is the average distance from the mean. Okay, so this would be if we see here, like the mean is 82.5. If we were to do 91 minus 82.5, 78 minus this, but we take the absolute value of it, 94 minus 82.5, and then 82.5 minus 67, and we add those four values up and take the average, that's how we would actually calculate standard deviation by hand without the calculator. But if you think about it conceptually, Joe got a 67 on one test, so that's a pretty low score relative to his other scores. Since his scores were fluctuating more, he has a higher standard deviation. Like his scores are farther away from the average. Whereas Andrea, her scores are sort of close together here. That's why she has a lower standard deviation. So 1 is out. 2, both the mean and standard deviation of Joe's test scores are higher. That's not true. Andrea has a higher average than Joe. So this one, 2, is not true. The mean of Andrea's test scores is higher than Joe's, but Joe's standard deviation is higher than Andrea's. That is the one, okay? We could see that Andrea's average is higher, but the standard deviation for Joe is higher. And then here we have the mean of Joe's test scores is higher. That one is right away not true. Definitely 3. Question 5 is straight vocabulary. Which polynomial has a degree of 3 and a leading coefficient of 2? So a degree of 3 means the highest power of x is going to be 3. Okay, so the highest power of x is 3. And that means, like, what I think about when I hear that is we're going to have something x to the third plus and a bunch of stuff. But we have a leading coefficient of 2. So a leading coefficient of 2 means that there's going to be a 2 in front of the x to the third. So just looking at the answer choices right away, choice 4 jumps out. See how we have a 2x to the third. So degree 3 and a leading coefficient of 2 means that the 2 is going to be in front of the x to the third. If we look at why the other answer choices are wrong, this one here is degree 2. See, the highest power of x is x to the second, so this one is out. This one is degree 3, but the leading coefficient is 6, not 2. So that one is out. And then here we have a degree of 2, which is not what we need. We need a degree of 3, so 3 is out. Definitely choice 4. Question 6, the expression negative 3x squared plus 9 minus parentheses 7x squared minus 5x plus 4 is equivalent to, and we have these 4 options to choose from. Well, for questions like this, just know when you are subtracting polynomials, you have to distribute the negative, okay? So this has to go all the way through. Okay, so for this, I like to do this. I go negative 3x squared plus 9, but plus 9, I'm going to give a little space here, and you'll see why in a moment. So we're going to send the negative through, and that makes this a negative 7x squared, and then minus 5x becomes plus 5x, and then minus positive 4 becomes minus 4. So when you send the negative through, it changes the sign of everything inside. And what I like to do is I like to treat this almost like I'm doing an elementary school addition problem. If I had to do something like 123 plus 456, I would go 1, 2, 3, and then 4, 5, 6, and I would line everything up by place value, and I would just add everything up this way, okay, to make it neater. So that's what I'm doing here, but now we're in Algebra 1. So we could go from right to left or from left to right. It doesn't matter because we're combining like terms. So we have 9 minus 4 is positive 5, so I write my plus 5. And then we have this lone 5x, so the 5x just carries down with the plus sign. And then we have negative 3 minus 7 is equal to negative 10, so we have negative 10x squared. And now we just go looking for our answer choice. So we have negative 10x squared plus 5x plus 5, and this tells us choice 1 is our answer. Now, the most common mistake I see with this, so just be careful here. A lot of students, what they're going to do is they're going to go negative 3x squared plus 9. And when they subtract this, they're just going to put the minus in front of the first term like this. So they go like this, and they don't actually distribute the negative all the way through. And if you follow this one through, you get negative 10x squared. So this equals negative 10x squared. And then we get minus 5x. And then we get, after this term here, we could combine the 9 and the 4 to get plus 13. And notice if we were to do it this way, that instead we would get choice 4. But be careful, choice 4 is a very dangerous bear trap. Make sure, once again, you are sending the negative through, and that'll bring you to choice 1. But now let's say we forget the algebra, or we know how to do the algebra and we just want to check our answer. We could go to the y equals and we could type the expression in as is in the y1 spot. So we could put parentheses, negative 3x squared plus 9, close the parentheses, minus open parentheses, and then we have 7x squared minus 5x, and then plus 4. Close the parentheses, and now we write in our answer. We have negative 10x squared, and then we've got plus 5x plus 5. And if we did this right, when we press graph, the graphs should overlap completely. So we press graph and see how the graphs overlap completely. If I press second graph and go to the table, notice that for all of my x's here, my y values match for both graphs. So choice 1 is definitely correct. Question 7, the function h of x is used to calculate the average height in inches of a tomato plant x weeks after it is transplanted. These data are represented in the table below. Between weeks 4 and 12, the average rate of change in inches per week is, and for this one, we're finding the average rate of change. So we should know this formula. When you have a function, so let's say we have f of x, so f of x, and we're on the interval AB. If we want to know the average rate of change, I'm going to write this out. The average rate of change, I'll abbreviate like this. The average rate of change of f of x on the interval from a to b is f of b minus f of a over b minus a. Okay, so this is what I automatically think about when I hear average rate of change. I say, okay, the average rate of change of f of x on the interval AB is f of b minus f of a over b minus a. And this is us just basically finding the slope between 2 points. But the key is you have to think about which weeks or which time frame are you between. So since we are between 4 and 12, we're going to use x equals 4 and the corresponding y value, and we're going to use x equals 12 and the corresponding y value. So now we just write this out. We're going to be finding here, we're going to have h of 12 minus h of 4 over 12 minus 4. Okay, and this is very similar, once again, to doing y2 minus y1 over x2 minus x1 when we're finding slope. You could think of this as x1, y1, and you could think of this as x2, y2. It's the same exact concept. Okay, so now we just work this out. H of 12, so h of 12, if we look, the function value when x is 12 is equal to 60. So this gives us 60 minus, and now h of 4 is the function value when x is 4, and the function value when x is 4 is 12. And then we divide by 12 minus 4 is 8. And that gives us 60 minus 12 is 48, divided by 8, which is going to give us 6. All right, but if this is confusing to use the function notation here, what you could do is you could just think of this as the point 412 and the point 12 comma 60. And we're once again just finding the slope between these 2 points. So when we actually plug into the function, see how we're getting 60 minus 12 over 12 minus 4, and we get 6. So choice 1 is our answer. Question 8, Chloe is solving the equation x squared plus 5x equals 3x plus 3. Her first step is shown below. So we have the given here, and we're looking at step 1. So let's see, what did Chloe do? Well, to get from the given to this step here, it looks like Chloe, so we'll just write it over here. We have x squared plus 5x equals 3x plus 3. But it looks like Chloe moved all the terms from the right side over to the left. But how would we move this plus 3x over? We would do the opposite. We would do minus 3x on both sides. So that's minus 3x minus 3x. And if we work this out, that's x squared plus 2x equals 3. And then from here, Chloe did minus 3 minus 3. I mean, she did this all at once. So you can do minus 3x minus 3 all in one step. But I'm just breaking this down in pieces so it's easier to understand. But let's think about, in words, what did Chloe do each time? She subtracted equal quantities on both sides of the equation, which is allowed. So we look at the answer choices here, and we can see, all right, Chloe subtracted things on both sides. So she used the subtraction property of equality, which says that if we subtract equal quantities from both sides of the equation, that the equation is still holding true, okay? That we are allowed to do that. You are allowed to subtract equal quantities on both sides. It's not the zero product property, because this would justify why, if we were to factor this, let's say we went an extra step and did x plus 3 times x minus 1 is equal to 0. If we did this, this says we are allowed to say x plus 3 equals 0, x minus 1 equals 0. Okay, so this would be, going further along in the process here that we would use the zero product property. Commutative property, this is when terms flip. But this would be if Chloe, let's say for some reason, wanted this to look 5x plus x squared equals 3x plus 3. So if she just flipped terms on both sides, then she's using commutativity. And distributive property would be if there were parentheses and we send something through. So not 3, definitely 4. Question 9, which function represents the graph of w of x equals absolute value x shifted 2 units to the right? So for this one, if you know your transformation rules, then what you could do is you could just take the starting function here, and we usually call this the parent function. So we take the parent function and we run it through the transformation. So if we want to go 2 units to the right, we replace x with x minus 2. So we're looking for an answer choice that has absolute value x minus 2. And right away, we could see choice 2 is our answer. If we want to look at why the other choices are wrong, absolute value of x plus 2 would go 2 units left. Okay, so when you're actually replacing the x, the sign here tells you which direction to go, but opposite. So plus 2 would tell you to go to the left 2. Minus 2 would tell you to go to the right 2. But then when you're writing your plus or minus 2 away from the x like this, then the direction is the same as the sign. So for choice 3, this would be us going up 2, and then this one would be us going down 2. But remember, we do get a calculator for the test. So we could just go to the y equals, and we start with the parent function here, absolute value x. And to get absolute value x, we press math, go to the right to number. Absolute value is number 1, and we put our x in there. And then we just go through the answer choices one by one, and by the time we get to choice 2, so we have math, number, absolute value, and we write in our x minus 2. But when we get to choice 2 here, and we press graph, you could see the parent function is absolute value x, where the vertex where turning point is at 0, 0, and the turning point moves 2 units to the right. Okay, so choice 2 is definitely correct. Question 10, given the system of equations y plus 4x equals 5 and 2x minus 3y equals 10, a step in solving this system by using the substitution method would be, and we have these 4 options to choose from. So since we're going to be using the substitution method here, we should look at the equation that's easier to solve for one of the variables. So here, the first one, you could see that solving for y, all we have to do is minus 4x on both sides. And that jumps out at me because notice that we have, if we do minus 4x, we'll have 5 minus 4x. And a few answer choices have 5 minus 4x in them. So that's another way I see that we're going to target that first equation. So we have y plus 4x equals 5, and we solve for y by doing minus 4x on both sides. And just so that this matches the answer choices, I'm going to leave the minus 4x on the right because notice that we have the constant and then we have the x term after it. So we cancel out 4x minus 4x and we have y equals 5 minus 4x. And then what you do with the substitution method, once you solve for one of the variables, you plug that result into the second equation. So now we look here, we have y equals 5 minus 4x. And if we go here to the next equation, notice we have a y here. So we're going to plug in for that. So next we're going to have 2x minus 3 times y, I'm going to leave a space, equals 10. So now instead of minus 3y, we're going to plug in y equals 5 minus 4x. So we have 5 minus 4x. And now all we have to do is just scan the answer choices, and we could see that this is going to match up with choice 3. Question 11, which equation is equivalent to x squared minus 6x equals 27? So for this one, what we're going to be doing is we're going to complete the square. So we have x squared minus 6x, and then I'm going to leave a space, equals 27. And when you're completing the square, what you want to do is you want to look at the b term here. So the b term is negative 6. And what I mean by the b term, I'm just thinking about when we think of quadratics, we have quadratics that are in the form of ax squared plus bx plus c equals 0. And the b term is the term in front of the x. Okay, and for these type though, when we're completing the square, what we want to happen is we want to have a 1 in front of the x squared. So just so this is like more aligned with the actual completing the square technique, what you want to happen is you want a 1 in front of the x squared when you're completing the square. So you want it to say x squared plus bx plus some constant, but the constant could be on the left or the right. That part doesn't matter. So what we do then is we take the b value. So we're thinking about the b value here is negative 6. we divide it by 2 and then square it. So negative 6 divided by 2 is negative 3. So we have negative 3, and when we square it, we get 9. And that number, we'll just make this a little neater. So we have 9. That number we add to both sides. So I'm going to go plus 9 on the left and plus 9 on the right. And what that does to the left side, it turns the left side into what we call a perfect square trinomial. Okay, that's why they call it completing the square, because it turns the quadratic, that expression, into a perfect square trinomial. Because when we're factoring this, we're looking for two numbers that have a sum of negative 6, and the two numbers have to have a product of positive 9. And the numbers that fit the description here are going to be negative 3 and negative 3. Negative 3 plus negative 3 is negative 6, and negative 3 times negative 3 is positive 9. And then on the right side, we're just going to leave this as 27 plus 9. And now here, I could just call that x minus 3 squared equals 27 plus 9. And if we look, this is going to match up with choice 2. Question 12, the box plots below summarize the ages of athletes on the swim team and the track team. Based on the box plots, which statement must be true? So for this, we have to know the anatomy of a box plot. The first value here is the minimum. Okay, so this is the minimum. And then this piece here is Q1. The second piece I could call Q2, but that we usually just call the median. Okay, so that's the median. And then the next piece here, this is the quartile 3. And then the last piece here is the maximum. Okay, and when you're looking at the interquartile range is Q3 minus Q1. Okay, so Q3 minus Q1. And then we have, let's see, the median age. So median is this part here. And the range, so the range is another term to look out for. The range is the maximum minus the minimum. Okay, so that's just something to, be mindful of. So now let's go through these. The interquartile range of both teams is the same. Well, that we would actually just have to calculate. So here, Q3 is at 16. So we'd have 16. So I'm going to find the interquartile range for the swim team. We're going to have 16 minus 12, and that's equal to 4. But if I do the interquartile range for the track team, I'm doing Q3 is this part here is 14, minus this part here is 10. And right away, we get 4 for both, so choice 1 is our answer. But let's see why the other answer choices are no good. There are more athletes on the swim team than on the track team. Well, all we have here is the ages of the athletes on the swim team and track team. So this isn't telling us how many athletes are on the actual team here. So that we can't determine based on what they gave us. So this is out. So now we have the median age. So the median age of the swim team is 13. So the median age of the swim team, so they're saying here 13 is less than the median age of the track team is 12. But 13 less than 12 is not true. So 3 is out. The range of ages of the swim team is smaller than the range of ages on the track team. Well, on the swim team here, the range of ages we have from 9 to 17. So the range for swim, so I'll just say that over here, the range would be 17 minus 9. And if we do 17 minus 9, that's going to give us 8. And then the range for the track team would be 15 minus 8. See, we're going from 8 to 15, and that would be a range of 7. So the range of ages on the swim team is 8, is smaller than the range of ages here is 7. So that's also not true. Definitely choice 1. Question 13, the graph of f of x is shown below. The domain of this function is, and we have these 4 options to choose from. So when you're looking for the domain, this is all of the possible x values, okay? So this is the possible x values. And for this, the key is to look at the graph and go from left to right. So where does the graph start if we're looking all the way left? The graph starts over here at 0. But notice that it's open here. Okay, so the fact that the graph is open at 0 means, so this means my thought process for this is that x equals 0 is not in the domain of f of x. Okay, so this x equals 0 is not in the domain of f of x. So that means something like choice 1, we could just chop out right away because you see how they put a bracket here. We would need a parenthesis to show that 0 is not included. Okay, so that's like a very sneaky detail to be mindful of. But if we count out here, notice we go out to 11, 12, the graph ends here, but this one is closed. And this means that, the thought process for this is that x equals 12 is in the domain. Okay, so x equals 12 is in the domain of f of x. But the x values that work are all of the x values going from 0 to 12, but not including 0, but 12 is included. So if I were to write this in the interval notation here, I would say parentheses 0 and then a bracket around 12, because 0, x equals 0 is not included. There's an open circle here, and a closed circle here means 12 is included, which we communicate with the bracket. Or we could say 0 is less than x, which is less than or equal to 12. We put the equal to on 12 to include it in the domain. Choice 3 is our answer. Question 14, the sum of 3 and square root 5 is, and for this, first we have to determine if that sum is rational or irrational. So notice that we have this square root over here. We have square root 5. And just know when you take the square root of a perfect square, something like square root of 1, square root of 1 is equal to 1 because 1 times 1 equals 1. And this number is rational because it's a whole number. Rational numbers in general are just numbers that could be expressed as the fraction of two integers, where the denominator is non-zero. But whole numbers also count as rational numbers. And if I had something like, let's say, square root of 4 is equal to 2, because 2 times 2 is equal to 4, and this is also rational. And the same thing with square root of 9. Square root of 9 equals 3. So these numbers here are all rational. So this one, and this one. But when you have the square root of a non-perfect square, 5 is not a perfect square. That's when you wind up with something that is irrational. Okay, so that's just a quick way to identify if a number is rational or irrational. 5 is not a perfect square, so this number here is irrational. And what that means is that this is going to be an infinite decimal that cannot be expressed with a specific pattern. It's not going to be repeating, and it's not going to terminate. Okay, it's just going on. It's infinite. So when we add a whole number and an irrational number, a rational, or like a whole number here counts as a rational number, but a rational number plus an irrational number is irrational. So right away, these two choices are out. And then we have these remaining answer choices. Irrational, since the sum can be expressed as a terminating decimal. Well, that would mean the number is rational, not irrational. So that reason is not correct. So right away, 4 has to be our answer, and the sum is irrational since the sum cannot be expressed as a terminating or repeating decimal. But if you have a hard time remembering if this works out to something rational or irrational just by thought process, then you could go to the main screen. So I'm going to press second mode to quit the graph. And we do the sum of 3 and square root 5. So we have 3 plus second x squared to pull up a square root. And I have 3 plus the square root of 5. And notice that I get this infinite decimal here. It's just going to go on and on forever here. And it's not repeating here. So that's how I would know here that we do not have a terminating decimal, that this one here is just not behaving nicely. Okay. If you have an infinite or non-terminating decimal, that doesn't automatically mean your number is irrational. If I had something like, let's say 12 over 99, 12 over 99 is, notice, the fraction with two integers. And if I press enter, I get a repeating decimal here. Okay, so repeating decimals are fine, which is why 4 is really good. It says, hey, the number here is cannot be expressed as a terminating or repeating. Okay, so infinite, just know, doesn't always mean that your number is irrational. If it's repeating in infinite, then it's a rational number, something like 12 over 99. But in this case here, choice 4 is our answer. Question 15, which expression is equivalent to a to the 8th minus b to the 6th? And for this one, it really helps to know this rule. A to the b to the c power is equal to a to the b times c. When you have a power to a power, you could just multiply those powers together and get your exponential expression. So just looking at what they have here, I could see that choice 3 is our answer. Because if you notice this part here, we have a to the 4th to the 2nd minus b to the 3rd to the 2nd. For the first piece, so I'm focusing here, a to the 4 to the 2 simplifies to a to the 4 times 2, which is 8. Okay, so that's how this part here would simplify. And then we would have minus, and if we focus on the next piece here, so this piece over here, the b to the third to the second, I'll write that over here. I use this property again, and I'm going to do b to the 3 times 2 is 6. So that's how I know choice 3 is our answer. Choice 4 is no good because if I do a to the 6 to the second, then I would get a to the 6 times 2 is 12. All right, the time to add the powers together is if it were a to the 6 times a to the second, then you would do a to the 6 plus 2, which would be equal to a to the 8th. But that's not what's happening here, so 4 is out. And then these are no good because with these, it is tempting to say 4 times 2 is 8 and 3 times 2 is 6. But the problem is to expand this, we would have to do a to the 4 minus b to the third times, and then we would have a to the 4 minus b to the third. So we'd actually have to expand this and use the distributive property or FOIL it, and we would have a middle term as well. This just has 2 terms here, but if we expand this one, we would have 3 terms, and the same thing for choice 2. So these are out, definitely choice 3. Question 16, the sum of 2 square root 27 and 4 square root 12 is, and for this one, we have to know how to simplify radicals and add radicals together. We could just use the calculator for this, but I'm just going to show how to do this algebraically, just in case a question like this does show up in the part 2 or 3 section. So when you have a value a and b that are both greater than or equal to 0, what you could say that square root of a times b is equal to square root a times square root b. So this is a major idea that we're going to use for this question. So what I notice here, when we're adding these radicals together, we have square root of 27 and we have square root of 12. So what I'm going to do on the side here is I'm just going to simplify these. Square root of 27, I could break down to square root of 9 times 3. And then this could break down to, let me just make this a little bit neater. So we have 9 times 3, and we could break this down to square root 9 times square root 3. So I'm just using this rule down here. But when I factor my number, I want to use factors where one of them is a perfect square. So that's why I went with square root 9, square root 3. And now the square root of 9 is equal to 3, but the square root of 3 is irrational, so we just rewrite it like this. And what this tells us, simplified square root of 27 equals 3 square root 3. And now I'm going to do this for square root of 12. So square root of 12, I'll write this over here. We have square root of 12. I could say square root of 6 times 2, but 6 and 2 are no good because 6 is not a perfect square and 2 is not a perfect square. The big idea when you're simplifying square roots is you want to find perfect square factors. So 4 and 3 are better. So we would have square root of 4 times square root of 3, and then the square root of 4 is equal to 2, but square root of 3 is irrational, so we just rewrite it again like this. And now this would be radical 12 simplified. So now we're ready to work through this question. So we're going to find the sum of these two numbers. We have 2 square root of 27 plus 4 square root of 12. And we simplified this earlier. So we found the square root of 27 simplified. So in the next line, I'm going to write that over here. And we also simplified the square root of 12, which in the next line, I'll write over here. So in the next line, the 2 is just going to carry down. But now square root of 27 simplified to 3 square root 3. And now we have plus 4 times the square root of 12 simplified to 2 radical 3. So now we just do this. And then to simplify here, when we're multiplying a whole number by a radical, we have to multiply the whole number by the coefficient in front of the radical. Don't do 2 times 3 is 6 on the inside. We have to do 2 times the 3 on the outside is 6. So we get 6 square root of 3 plus 4 times 2 is 8. And then we get our square root 3. Once again, the numbers outside, we cannot multiply with the numbers inside. I can't say something like, oh, 8 times 3 is 24, so let me write this. That would be wrong. So we could only multiply numbers that are both radical terms with matching. If they're both square roots, then we can multiply these together to combine them like this. But this, once again, we can only do this if a and b, the numbers inside, are greater than or equal to 0. But now when we get to this step, this is a lot like doing if we had something like, let's say, 6x plus 8x would be 14x, okay? We combine like terms, we just add the coefficients. So now we're doing 6 plus 8 is 14. So this is 14 square root 3. Choice 1 is our answer. But of course, for something like this, we could just plug this into the calculator. So we have 2 square root 27, and we hit the right arrow to get out, and then we press plus. 4 square root is second x squared. 12, and we press enter, and then we just run through all the answer choices. So 14 square root 3 should give us a match, and notice that we get an exact matching decimal here. So choice 1 is definitely correct. Question 17, the sum of Tim's age and Jack's age is 44. Tim's age is 4 less than 7 times Jack's age x. An equation that could be used to model this scenario is, and we have these options to choose from. So for this one, I'll just write out Tim and Jack. So we have Jack and we have Tim. And this is the type of question that you might have to reread it more than one time. So we have Jack's age is X. So I'm just going to put an X by Jack's age. And then they tell us Tim's age is 4 less than 7 times Jack's age. So for this one, it is tempting to say, ooh, 4 less than, I'm going to say minus, and then 7 times Jack's age x. But this is a very dangerous bear trap. When you hear 4 less than, this means that you're going to have to switch and subtract. Okay, switch and subtract. So what that tells us is we're going to have to rewrite this. We're going to go with 7 times Jack's age x is 7x, but 4 less than that would be minus 4 after. Okay, so if you reread that a few times, you'll be convinced 4 less than 7 times Jack's age x would actually be 7x minus 4. But now they're telling us to write an equation here that models this. We have the sum. Okay, so if we look here, the sum tells us to add these. So we would have 7x minus 4 plus x, and they're telling us the sum of their ages is 44. So we set this sum equal to 44, and now these answer choices are out. This one here was the trap that I talked about before, and choice 1 would be our answer. Question 18, given the function g of x equals 2 to the x plus 3 over x squared minus 2, what is the value of g of negative 2? So for this one, I'll show how to do this by hand, and then I'll show how to use the calculator. So g of negative 2, this tells us to replace all of the x's with negative 2. So we have an x here, here, and here, and the x on bottom is being squared. So we plug in, we have 2 to the negative 2 plus 3. And this one, I could put negative 2 in parentheses like this, but since I'm just adding, I don't actually need to write the parentheses. But just so that we practice good habits here, I'll put parentheses around this negative 2, because the x squared here, that negative 2 that I'm plugging in, now I absolutely have to write parentheses. Okay, so negative 2 squared and then minus 2. So once again, notice I'm just replacing all of the x's with negative 2, and I'm using parentheses in the expression to the right. So now we simplify this piece by piece. So this is going to be 2 to the negative 2 plus 3 is 1. And then when I have parentheses negative 2 squared, that gives me 4. And then I have 4 minus 2. So now g of negative 2, I could say is 2 over 4 minus 2 is 2. And 2 divided by 2 is equal to 1. So choice 1 is our answer. But if you just want to type this right into the calculator, you could press alpha y equals enter to pull up a blank fraction. And then we have 2 to the power, and we're plugging in x equals negative 2. So we have negative 2 and then plus 3. And in the denominator, since we have x squared, we have to write the negative 2 in parentheses like this. So we have negative 2 squared, and then we tack on a minus 2 after. And now we press enter, and notice that we get 1. The reason why I'm emphasizing the parentheses is if we do not write parentheses, if we just write, let's say, 2 to the negative 2 plus 3, and then in the denominator, I write negative 2 squared without parentheses, and then minus 2, and notice that we get a different answer. And of course, there's an answer choice waiting for us here. But choice 4 is a very dangerous bear trap. One thing to be very mindful of is the reason why the answer is coming out different is if we use parentheses, negative 2 squared is equal to positive 4. But negative 2 without parentheses squared is equal to negative 4. And the reason behind that, this is the same thing as saying negative 1 and then times 2 squared. And see how that gives us negative 4. So parentheses matter big time. But another workaround here, you could go to y equals, and I'll clear this out. And you could go to y1 and write in alpha y equals enter to make a fraction. And then you have 2 to the power x plus 3 And then in the denominator, you have x squared minus 2. And then from here, you can just press second graph and notice that when x equals -2, we have y is equal to 1. So choice 1 is our answer. And just notice all these fractions here don't look nice. So I'm going to press mode and go down to answers and switch from auto to decimal, because at the start of the video, I had the calculator reset. And I'm just doing that just in case you don't know how to navigate the calculator. I'll show some of those navigation skills as I go through the questions. Okay, but choice 1 is our answer to question 18. Question 19, 4 graphs are shown below. Which of the graphs represent or represents a function? So for this, it helps to know the vertical line test. So the vertical line test is a nice way to determine if a graph represents a function. And the way it works is you draw a vertical line through the graph. And if you could draw a vertical line at any place on the graph and it only touches the graph at one location, then that graph would represent a function. Okay, so A, I could see right away is a function because no matter where I place this vertical line, it's touching the graph at one location when I draw my vertical line. Okay, so A would actually be a part of the set of graphs that represent a function. So A is in, and every answer choice has A, so that doesn't narrow anything down. Choice B would be a graph here that would represent a function. I know we have a horizontal line, but if I draw a vertical line anywhere, that vertical line is only going to touch that line at one location. Okay, so B would also be in. So what that does is it eliminates choice 1 because B counts. And now C is no good because if we were to draw a vertical line exactly on top of the vertical line we're given, it would touch that vertical line at infinite places. So C is out. Okay, we can't have C as part of our solution set here. And another way to determine if you have a function is the repeating x value test. Repeating x values are no good. So let's say this was x equals 2. So x equals 2. And then let's say I have 1 here and I have, let's say, -2 down here. If these 2 points are on my line, that means that when x is equal to 2, and I look at my range here, that I have 2 going to 2 places. I have it going to 1 and -2. And if your x is repeating for different y values, then you do not have a function. Okay, if I were to write these out as ordered pairs, that means I have the point 2, 1, and I have the point 2, -2 on my graph. So you see I have repeating x values and different y values. So that's another reason why C is out, other than the vertical line test. And now if we look down here at this graph of the circle, if I were to draw a vertical line at this location, notice that the vertical line would hit the graph twice. Now, some students might say, wait a minute, if I draw my vertical line over here, then it doesn't touch the graph at all. So is it a function? But the goal isn't to avoid hitting the graph twice. If there's any vertical line you could draw that touches the graph twice, then that eliminates that graph as being a function. So now D is out as well. So we just have A and B only. Choice 2 is our answer. Question 20, the formula to calculate kinetic energy is K equals 1/2 mv squared, where K is kinetic energy, m is mass, and v is velocity. When m is written in terms of K and v, the equation is. So for this one, we're going to solve for m. So we have K equals 1/2 mv squared. And if we just go piece by piece here, we want to move one term over at a time. And let's get rid of this 1/2 first. I'm just going to give a little space here. I'm going to move this over like this. To get rid of 1/2, we could multiply both sides by 2. So if I go times 2 on the left and times 2 on the right, 2 over 2 cancels. So now I would have 2k equals mv squared. And our goal is to solve for m. So I'm just going to do more algebra to get m by itself. So we have m times v squared. So we would divide both sides by v squared to get m alone. So now we have v squared over v squared canceling. And this tells us that m is equal to 2 times k over v squared. And this is going to match up with choice 1. Question 21, the solution to the equation 2 times parentheses 3x minus 1 over 3 equals x plus 2 is, and for this one, what I'm going to do is I'm going to solve this algebraically first, and then I'll show how to use the calculator to get right to the answer. So we have 2 times parentheses 3x minus 1 over 3, and this is equal to x plus 2. And for this one, there's a few different ways we could start this. But one thing we could do is we could call the right side x plus 2 over 1, and then we could cross multiply. So if we cross multiply here, we have 2 times 3x minus 1 times 1. And when you multiply by 1, the first thing doesn't change. So we're going to have 2 times 3x minus 1. And then equals, we have 3 times x plus 2. But for this one, we have to be very careful. We have to make sure we use the distributive property. So now in the next part here, we're going to distribute. So let's just change colors here. So we're going to do 2 times 3x, and I'll write that over here, is 6x. And then we have 2 times negative 1 is negative 2. So I'll just make that a little neater. So we're going to have 6x and then minus 2. And then once again, we distributed the 2 to the 3x and the 2 to the minus 1. And on the right side, we have 3 times x is 3x. And we have 3 times 2 is equal to 6. And now to solve, we could go minus 3x on both sides. We want to get the x's all on one side. So 3x minus 3x cancels. And then we have 6x minus 3x is 3x. And then minus 2 equals, we're left with 6 on this side. And now we could go plus 2 on both sides. And we're going to have minus 2 plus 2 cancels. 3x is equal to 6 plus 2 is 8. And now finally, just divide both sides by 3. And this tells you that x is equal to 8 over 3. So choice 4 is our answer. But another way to do this would be to go to the y equals, and we could type the left side of the equal sign in the y1 spot and the right side in the y2 spot. So I'm going to press alpha y equals enter to make a blank fraction. And then we have 2 parentheses 3x minus 1 and then over 3. And now for the second equation, we're going to write in the right side of our equations, the equation we have here, the right side is going to go in the y2 spot. So we're going to have x plus 2. Okay, so this will solve any equation that has a solution. You could just type the left side in the y1 and the right side in the y2. Okay, this is a very valuable skill to have, not just for Algebra 1, but it's useful for your future math classes as well. So now I'm just going to press graph, and notice that the graphs intersect over here. So now I can press second trace 5 to see where do the graphs intersect. And then I go nearby and I just press enter 3 times and I get 2.6 repeating. And if you go to the main screen, 2.6 repeating, if I were to just write this out like this, so 2.6 repeating, I just type in a bunch of 6s like this and I press math, enter, enter, this will turn into 8/3. Okay, so choice 4 is definitely correct. But just know another big idea is that the relationship between the solution to this equation and the graph is that when I graph left side and right side, the point of intersection, the x value at the point of intersection is representing the solution to this equation. Question 22, which equation represents the sequence we have 12, then 6, then 3, then 3 over 2, where a sub 1 is equal to 12? So this represents the first term of the sequence. So you could say a sub 1 is equal to 12. The second term in the sequence would be a sub 2. A sub 2 is equal to 6. A sub 3 is equal to 3. And a sub 4 is equal to 3 over 2. And what I like to do for questions like this is first I like to identify what's the pattern. And to go from one term to the next, what's going on here is that we are dividing by 2. We're doing 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 2 is 3 over 2. So we could say we're dividing by 2, or we could say we are multiplying by 1/2. So this is going to be a geometric sequence here because we are multiplying by the same thing to get from one term to the next. So there's a nice formula to have here. We have a sub n equals the first term times the r value we call the common ratio. Okay, so this is our common ratio. And that's the term we're multiplying by each time to get from one term to the next. And this is our first term. Okay, and then this is the, after this is the nth term. Okay, but this formula is really nice. We just need a power here. It's going to be to the n minus 1 power. Okay, so it's a sub n equals a sub 1 times the common ratio r to the n minus 1 power. And what we do is we just plug right into this. So we have a sub n equals the first term is 12 times r, the common ratio, is equal to 1/2, and now to the n minus 1. Okay, and we just scan the answer choices here and see this is going to match up with choice 1. Now, if you're struggling to find what the common ratio r is equal to, all you have to do is take any two consecutive terms and divide them. So I could take 6 and 12 here. Well, we have 12 first and then 6. And I divide the term 6 by the one before it. So I do 6 over 12, and that simplifies to a half. If I wanted to, I could even take these two. I could take 6 and then 3 and say r is equal to the term 3 divided by the one before it is 6, and that also reduces to a half. Okay, so that's just a nice way to find the common ratio very quickly, but choice 1 is our answer. Now, one thing I want to point out before we move on, but for that last question, that geometric sequence formula is not something you need to memorize. This is one of the formulas that they give you on the reference sheet here. So it's good to know for the Regents, just talking about strategy here, is you could rip this page off at the beginning of the test and just have this next to you. So if any questions pop up that mention any of these terms, you'll just have these equations on the ready. Question 23, the axis of symmetry is x equals 2 for which quadratic function? And we have these 4 options to choose from. So for this, we could also refer back to the reference sheet, and one of the equations that's on the reference sheet is the equation for the axis of symmetry for a parabola. And the equation is x equals negative b over 2a. And just know that this equation works when you have something in the form of y equals ax squared plus bx plus c. So as long as you have a quadratic equation written like this, you could find the axis of symmetry using this formula here. But for something like choice 1, we could just look at the graph and see that we have 1, 2, 3. This is the x value here where our axis of symmetry would be. So this axis of symmetry is actually x equals 3. So choice 1 is out. Okay, this would not be an axis of symmetry of x equals 2. All right, so this one here is just not lined up nicely. So this one's out. And now we move on to choice 2. So if we look at this one, we have 2x squared plus 8x. So here we have an a value of 2 and a b value of 8. So if we plug in, so for choice 2, I'll just write this in red. For choice 2, we're going to have x equals negative b. So we'll have negative 8 over 2 times 2. And this would give us negative 8 over 4, which would give us negative 2, which doesn't match the positive 2. So this answer choice is out. And now I'll do choice 4 just because it's in the same form as choice 2. So this one, we would have an a value of 1 and a b value of negative 4 and a c value of negative 5. So if we plug into the axis of symmetry formula, we would have x equals negative 4. We have to write that negative twice over 2 times a is equal to 1. And this would give us positive 4 over 2. So x equals 2 would be our axis of symmetry. So choice 4 is definitely our answer. Now, let's think about why is choice 3 no good? Well, if we were to just sketch this out, so I'm going to draw out an xy axis like this, and we have the point negative 2, 6. So I'll say negative 2, and then up 1, 2, 3, 4, 5, 6. So negative 2, 6 would be over here, then negative 1, 3, and then we would have 0, 2, and then we would have 1, 3, and then we would have 2, 6. So this parabola would look something like this, but notice that the axis of symmetry is on the y-axis, and the y-axis is the line x equals 0. And you can even see here the vertex, the turning point, is here. And when you have the vertex, the equation for the axis of symmetry is just the x value there. So x equals 0, once again, is our axis of symmetry. So 3 is out. Definitely choice 4. Question 24, each day a freight train passes by Anna's house. This freight train travels at 49 miles per hour. Each railroad car is 56 feet long. Which expression represents the number of railroad cars that pass by Anna's house per minute? So for questions like this, they get a little bit tricky to, understand what's going on, but there's a nice way to think about them that makes it much simpler. So I look at what units we want at the end. Which expression represents the number of railroad cars that pass by Anna's house per minute? So I'm just thinking the end result is we want cars per minute. That is what we want at the end. Okay, this is what we're aiming for. So that's what I'm thinking about. And now the simpler version of this is true story. I am 6 feet tall. So I am 6 feet tall, and I tell the class that, and then I ask my students, how many inches tall am I? and they'll say 72 inches. You do times 12. But the thing is, we're not just multiplying by 12. We're using the idea that 1 foot is equal to 12 inches. So what we're really multiplying by is we're multiplying by 12 inches over 1 foot. And we're allowed to do this because 12 inches equals 1 foot. So these are equal quantities here. Okay, so these two things here are equal quantities. So since we have a numerator and denominator with equal quantities, this allows us to just multiply by 12 inches over 1 foot, and it doesn't change the value of the original number, just the representation. And then feet over feet cancels. 6 times 12 is 72, and the inches is the new unit that we're dealing with here. So this thing over here on the side is called a conversion factor. So we can multiply by equation factors, and they don't change the value of the original number, just the representation. But the simple way I go through these questions is we need the units to cancel out like this in order for the conversion factor to be good. So when I look at, let's say, 49 miles per hour, and we want to wind up with cars per hour at the end. Well, here I look and I see, all right, we're doing miles times miles. So at the end, we're going to have a number and then miles squared, which is not what we want, so 1 is out. Here, let's see, we have miles times miles is once again miles squared. So this answer choice is also no good. And then here, we have miles over miles cancels. We have hours over hours cancels, and we have feet over feet cancels. And then we're multiplying these numbers together, 49 times 5,280 divided by 60 times 56. But at the end, we're left with cars per, and we're left with minutes on bottom, which is exactly what we wanted. So 3 is looking good right away, but let's see why 4 is no good. So here we have miles over miles canceling, but notice we have hours times hours on bottom. So if we have the same unit on bottom, we would have to multiply them, and in the denominator, we would have hours squared, which doesn't make sense. We want cars per minute. So that's why 4 is out. Definitely choice 3. So now moving on to the part 2 questions. There's 6 questions here, and each one is worth 2 credits. Question 25, a survey was taken to determine whether students preferred to watch videos or listen to music. Of the 100 students surveyed, 44 were seniors. Of the 65 students who preferred to watch videos, 42 were juniors. Use this information to complete the frequency table below. So for questions like this, I just go piece by piece, and I wind up rereading the information that they give. So here they tell us there's 100 students in total, and they tell us that there are 44 seniors in total. So this part here, the 44 seniors, we could just write in the total spot here for the seniors. And then what we have next, we have of the 65 students who preferred to watch videos. So I look at the watched videos, and in total, there are 65 students who prefer to watch videos. And here they tell us that 42 of those students are juniors. So of the total 65 people who prefer to watch videos, 42 are juniors. So right away, we could find out how many seniors prefer to watch videos if we subtract. If we do 65 minus 42, this is going to give us 23, and this tells us 23 seniors prefer to watch videos. And if we were to add up 42 plus 23, that would give us the total 65 here. And now we could find something else. Now we could find out how many seniors listen to music, because what we have here is we have the number of seniors that watch videos, and we have the total number of seniors. So if we do 44 minus 23, this gives us 21, and this tells us 21 seniors listen to music. And now we just continue from here. What we could do next, they told us 100 students were surveyed in total. So this information we could record over here. And now we just start subtracting other stuff. So now we could just do, let's say this entry here, how many students in total listen to music. We could do 100 minus 65, which is 35. And that information could go here. And now everything just starts to unravel here. It's kind of like a domino effect. Once you find enough information, you could just start to find the rest. So let's say now I want to find this entry. How many juniors listen to music? I could take the total number of students that listen to music, which is 35, and subtract the number of seniors that listen to music, 21, and this gives us 14. So now we have 14 juniors that listen to music. And the last piece here, we could find a few different ways, but one way would be to add the total number of juniors. So if we do 42 plus 14, we get 56. And a nice check here, if we were to do 56 plus 44, that would also give us 100. So here is our complete frequency table. Question 26, we have to solve the inequality for y. And for this one, we're just going to go piece by piece. So I see the parentheses here with the 5 in front. So my first instinct is to use the distributive property. So I'm going to send this 5 through by multiplication. So we have 5 times 2 is 10, minus we have 5 times y is 5y. And this is greater than, we have negative 11y minus 8. And now from here, we want the variable terms, or the variable term to the left, and we want the constant terms to the right. So what we could do now is go plus 11y on both sides. So we could go plus 11y, and on the right side, minus 11y plus 11y cancels out. And we have 10, and then negative 5y plus 11y is going to give us positive 6y. And this is greater than negative 8. And then from here, all we have to do is just subtract 10 on both sides. Okay, remember the goal is to solve for y. Okay, we want to solve for y. So this is the piece that we're targeting. So we want to just start moving everything away from the y variable. So now on the left side, 10 minus 10 cancels. And then we have 6y is greater than negative 8 minus 10 is negative 18. And now from here, we divide both sides by 6. And we could simplify. We could say that y is greater than negative 18 divided by 6 is negative 3. And then here's our solution to 26. Now, one thing I want to point out is when you are solving inequalities, if you multiply or divide both sides by a negative, the sign has to flip. But even though we divided negative 18 by 6, we never actually multiplied or divided both sides by a negative. That's why the inequality sign stayed greater than the whole time. So y greater than negative 3 is our solution. Question 27, express 5x minus 3 times negative 2x plus 7 as a trinomial in standard form. So for this one, we have to multiply these two binomials. And for this, I like to use the distributive property. Now, you can use FOIL, but the reason why I don't go to FOIL right away is because if we had to multiply a trinomial by a binomial, then we can't use the FOIL method. Okay, so the distributive property works for any case. So what we do though is we start with the first set of parentheses and we distribute each term one by one. So the 5x I'm going to send through first. I'm going to do 5x times negative 2x, and that's negative 10x squared. Okay, I'm doing 5 times negative 2 is negative 10, and x times x is x squared. And then I would multiply 5x by the 7 next. So we have 5x times 7 is going to give us 35x. We're just doing 5 times 7 is 35, and the x just tags along. And then next, I would distribute the negative 3. So we do negative 3 times negative 2x, and we have a negative times a negative, which goes positive. So we have plus 6x after we do 3 times 2 is 6. So now, next we're doing negative 3 times 7, which is negative 21. And then from here, all we have to do is combine like terms. And they're telling us to write our final answer as a trinomial in standard form. So that means that we have to write this in simplified form, and we have to write the highest power of x to the left, and then we have to go in descending power order. So we're going to go negative 10x squared, and then we have 35x plus 6x. We just do 35 plus 6 is 41, so we get plus 41x, and then we get minus 21 at the end. So here is our trinomial in standard form. Question 28, the first and fourth terms in an arithmetic sequence are given below. So we have negative 20 is the first term, the second and third terms are missing, and negative 2 is the fourth term. And we have to determine the eighth term. So for this one, I'll do the algebraic method first, and then I'll show how you could just do this by brute force. So since we are dealing with an arithmetic sequence, that means the same thing is being added each time to get from one term to the next. So we could say our first term, a sub 1, is equal to negative 20. And then a sub 2, we don't know, but what we do know is that to get from the first to the second term, we're just adding some number. And we call that number d, the common difference. And then the third term, we're adding the common difference again. So if we go negative 20 plus d plus the common difference again, this would be negative 20 plus 2d. And then the fourth term would be negative 20 plus 3 times the common difference because we're just adding d again. But we know the fourth term is negative 2. So what we could do with this is we could say that negative 20 plus 3d is equal to negative 2. And we could solve for the common difference. So now we just go plus 20 on both sides. And from here, negative 20 plus 20 cancels. 3d equals, we have negative 2 plus 20 is 18. And now we divide both sides by 3. And this tells us the common difference is equal to 6. But now that we have the common difference, we could use the formula from the reference page for an arithmetic sequence, which is a sub n equals a sub 1 plus n minus 1 in parentheses times the common difference d. So now we could just plug in what we know. We know that the first term, a sub 1, is equal to negative 20. And then we have plus n minus 1 times the common difference. So I'm just going to write plus 6 times n minus 1. And then because multiplication is commutative, I could just flip those two. So if we're looking for the 8th term, our goal is to find the 8th term. We could just say a sub 8 is equal to negative 20 plus 6 times, and then we have 8 minus 1. And this is going to give us negative 20 plus we have 6 times, this is going to give us 6 times 7, which is 42. And then if we do negative 20 plus 42, that's going to give us 22. Okay, so that would be the 8th term. But I just want to point out, this is a lot of work. So let's say you just want to play guess and check until you find the common difference. So this method here, this is just an additional method. Don't actually write brute force, but that's basically what we're doing here. And we find out, hey, the common difference is 6. Like maybe you try out 1 first and you're like, all right, plus 1 is negative 19, plus 1 is negative 18, plus 1 is negative 17. And it's like, all right, it's not 1. And you just keep trying until you say, all right, the common difference is 6. Well, then you could sit there and you could just make a list. Okay, you could start at negative 20. So negative 20, and then you just add 6 and you get negative 14. You add another 6, you get negative 8. You add another 6, you get the 4th term, which we said was negative 2. You add another 6, you get 4, then you get 10, and then you get 16, and then you get 22. So you could, once again, just sit there and make a list and then just say, hey, my 8th term is 22. This is much faster, but I just wanted you to see a technical approach to this question. Because if they said something like, hey, find the 800th term, you're not going to want to sit there and make a list of 800 numbers. That's where the algebra makes more sense. But for the 8th term, this would actually be a pretty reasonable way to do this question. Question 29, write an equation in slope-intercept form for the line that passes through negative 2, 5 and has a slope of negative 3. And the use of the set of axes below is optional. So there's a few different ways we could do this, but one way to do it would be to use this formula, y equals mx plus b. So this is the slope-intercept form equation of a line where m represents the slope and b represents the y-intercept. The slope tells you the direction the line is going, if it's going up or down, and the y-intercept tells you where the line crosses the y-axis. And here in the question, they gave us a point that's on the line. So the point represents xy, and the slope represents the value m. So what we do with this information is we plug it into this equation to solve for the y-intercept. So let's go ahead and do that. So we have y equals, so we're going to have 5 equals. We're just replacing y with 5. And now the slope is negative 3. And the x value here is negative 2. And then we have plus b. So this will tell us what the y-intercept b is. So now we have 5 equals negative 3 times negative 2 is positive 6. And then plus b. And then from here, we just subtract 6 on both sides. And this tells us that b equals negative 1 because we have 5 minus 6 is negative 1. And 6 minus 6 cancels on this side. But once we get to this step, we have to make sure we actually answer the question. The question is asking us to write the equation in slope-intercept form for a line. Okay, so if we stop here, we're only going to get partial credit. For full credit, we actually have to make the substitution into the formula for m and b. So our final answer would be y equals, and now the slope m is still negative 3, so we have negative 3x, and then plus b, but our b value is negative 1, so I could say plus negative 1, or I could just say minus 1. And then this would be our equation. Now, they said the use of the set of axes below is optional, but if you wanted to answer this question without using this formula, what you could do is you could start at the point negative 2, 5. So we could plot that point. We go to the left 1, 2, and up 1, 2, 3, 4, 5. So here's the point negative 2, 5. And then when I hear that the slope is negative 3, for one, I hear slope, and I think rise over run. Okay, so the slope tells you the rise over run of the line. So when we have a slope equal to -3, I could write -3 as -3 over 1. And then this tells me that we're going to rise -3 and we're going to run 1. But if we rise -3, that means we're going down 3 and then to the right 1. So we go down 3 to the right 1. And we just keep doing this. Down 3 to the right 1. And we could just keep repeating this. And what happens by the time we get to this point here, when we connect these points, we'll know from the graph what our y-intercept is. Okay, so our y-intercept is over here at -1. So the b value -1 matches what the graph is saying here. Okay, so if we don't want to do any of this work over here, we could use the graph to solve for the y-intercept and then just write this answer like this. Okay, but the formula is very nice to use, but either way, we're getting y equals -3x minus 1. Question 30, factor the expression x to the third minus 36x completely. And just know when you hear the phrase factor completely, that means that you're probably going to have to factor more than one time. Factor completely means that you have to keep factoring until you can't factor anymore. So when I'm factoring something completely or just factoring in general, I always look for a greatest common factor first. So if you look at this expression here, the greatest common factor is x. And one way to see that is that if we expand the first part, x to the third, as x times x times x, you could see when we have x to the third minus 36x, that there's one x in common that we could take out. Okay, so that's what it means when we're looking for a greatest common factor. We're seeing how many of the factors do they have in common that we could take out. We want to take the greatest amount out possible. A shortcut, though, if there's a lot of terms, is that you just look for the lowest power of x that shows up, assuming that all of your terms have an x. So the fact that x to the first is the lowest power of x tells us our greatest common factor is x. So now we write the greatest common factor on the outside, and then on the inside, we have x to the third, but we're going to divide x to the third by the greatest common factor x. And then we have minus 36x divided by the greatest common factor x. And that's the math that I'm doing in my head when I start these questions. So we have x on the outside, and now when we do x to the third divided by x, this one, if you just know that it's x squared, then great. Otherwise, what you could do is just use this rule. So we could just think of this as the rule a to the b over a to the c, and we do a to the b minus c. So here, when we're doing x to the third divided by x to the first, we're really doing x to the 3 minus 1, which is x to the second power. And now here, x over x would just cancel, so we would have minus 36. But remember, the question said factor completely, so that usually means we're going to have to do another step. And the next technique that we need here is difference of two squares factoring. So when you have a squared minus b squared, this factors nicely to a plus b times a minus b. So for the next line, we could say now that this is equal to x times, and now the x squared minus 36, we're going to factor that using this technique here. So just think of this as x squared minus 36, if I highlight this. So this part, if I write it over here, is the same thing as saying x squared minus 6 to the second power, which would factor nicely to x plus 6 times x minus 6. So that's what we're going to write over here. We have x plus 6 times x minus 6, and now we can't factor anymore. Okay, so this part, just so we see how it connects here, x squared minus 36 factors to this, but our expression here at the end is the original expression factored completely. So now we're moving on to part 3. There's 4 questions here, and each one is worth 4 credits. Question 31, we're going to graph f of x equals negative 3x and g of x equals x squared plus 2x on the set of axes below. And then we have to state the values of x that satisfy the equation f of x equals g of x. So to graph these, we might as well use the calculator to help us get an accurate graph. So we go to y equals, and we're going to type in, we have negative 3x is our first function here. We have f of x equals negative 3x. So that's going to go in the y1 spot. And then for y2, we're going to write our second function, g of x equals x squared plus 2. So we have x to the second power and then plus 2. But now we press graph and we get a picture. But to make this more precise when we transfer it over here, we're going to press second graph to pull up a table, because when we plot the points, we want everything to be as precise as possible. So when I do my graphs, I do like to make a little table on the side just so I could show what I'm trying to draw here on the graph. So first I'm going to write out the points for f of x. So we have x, and then we have f of x. And for this one, this is the linear one. So this is the one where the values are dropping by 3 each time. But I'm only going to pick the points here that actually show up on the grid. I'm not going to try to plot something like -5, 15, which flies off the page. So I'm going to start here at -3, and when x is -3, the y value is 9. And then we have -2, 6, we have -1, 3, we have 0, 0, we have 1, -3, then we have 2, -6, and then we get 3, -9 is going here. And then for the other function here, for g of x, and I'll just make a little space here so that we can fit both tables on the side. But for g of x, what I'm going to do is I'm going to include the values once again that show up on the graph. So we have x, then g of x. And for this, I'm going to start at -2. So we have -2, 6, and we have -1, 3, and then we have 0, 2, and then we have 1, 3, and 2, 6. Okay, so these are the points that we're going to plot. Okay, so I plotted these points and I connected them appropriately. So for f of x, we have a linear function, and for g of x, we have a quadratic. So I'm connecting this with the parabola. And now for the last part here, we just have to state the values of x that satisfy the equation f of x equals g of x. Well, what we're looking for on the graph is we're looking for where do the graphs intersect. They intersect when x equals -1, and they intersect when x equals -2. And if you want to enhance the graph a bit, what you could do is you could just write in a few x values and a few y values. So we have 0 here, we have 1 here. So I'll just put a dash and then I'll put the 1. So we have 1, 2, and then let's say this goes out over here to 3. Over here we have -3. And then I'll just show that we're scaling the y-axis here by 1 as well. So we have 1, and then we have 2, 3, 4. Okay, and this is going up 5, 6. I don't have to label it all the way here, but I'm just going to write in a few values just so I'm communicating this as clearly as possible. All right, but for the actual full credit here, we do not actually have to label the x and y axis with values here. Okay, especially if you write down the table like this, you could just draw the pictures like I did and then get right to the answer. So here, which values of x? We could say x equals -2 and x equals -1. And if I really wanted to be sure, what I could do is I could look at the table that we had in the calculator and notice that when x is equal to -2, the y values are both 6. And then when we have x is equal to -1, we get matching y values of 3. So that's really like the most definitive way is to look at the table or trace the intersection points. But we're going to have x equals -2, and we're going to have x equals -1. So here are the solutions to f of x equals g of x. Question 32, using the quadratic formula, solve 6x squared plus 2x minus 1 equals 0 and express the answer in simplest radical form. So for this one, we have to go to the reference page and get the quadratic formula. So on the reference page, they'll tell you x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So you could memorize this formula, or you could just go to the reference page and grab, this formula, when you need it. So in general, just know that a, b, and c represent the coefficients in a quadratic equation. So when you have an equation in the form of ax squared plus bx plus c equals 0, then we could say x equals, and then we plug in the coefficients to this formula here. So what I'll do next is identify the a, b, and c values. So a is the coefficient of x squared. So we have a equals 6. And then we have a b value equal to 2. And then c is equal to -1. Okay, the sign has to come along with it. And we're able to identify a, b, and c because the equation they gave us is equal to 0. So now we just plug into the formulas. We have x equals -b. So we're going opposite of +2, which will give us -2. And then we have the plus or minus. And then we have a square root. And then we have b squared. And for this part, I recommend that you use parentheses because in the event that b is negative, one of the most common mistakes I see is that when b is negative, students will plug in without the parentheses and then they type in the calculator and they get something different. So just be sure that when you're squaring something to put the term you're squaring in parentheses. And then we have -4 times a is equal to 6. and then c is equal to -1. And another common mistake that I see is that students will miss the sign change here. We're doing -4 times 6 times -1, and a negative times a negative goes positive. So just be on the lookout for that detail as well. And this is all over 2 times a, and a is equal to 6. So now we just start simplifying. If we plug into the formula correctly, we get 1 out of 4 points. But then from here, we have -2 plus or minus. And for this part, we could use a calculator, or we could just work out the math in our heads. And we have 2 squared is 4. But then we have -4 times 6 is -24. And -24 times -1 is +24. So we have 4 plus 24, which is 28. So we have square root of 28. And then this is all over 12. But the question did say to express the answer in simplest radical form. So if we stop here, we only have 2 out of 4 points. So next we have to target the square root 28 piece. Okay, so this piece over here, that's the radical that we have to simplify. So I'll do that off to the side. Square root of 28, I could say that 28 is equal to 14 times 2. But 14 times 2 is no good here because 14 and 2 are not perfect squares. So I wouldn't want to go with those two. So I'm going to go with square root 4 times square root 7 because 4 is a perfect square. And we could simplify the square root of 4 is equal to 2. So we get 2 square root 7 like this. Okay, so the square root of 4 is going to simplify nicely, but square root of 7 is irrational, so we just leave it as square root 7. And now we just rewrite this. So we have x equals -2 plus or minus, and then we have 2 square root of 7 over 12. And if we stop here, this will get us full credit. They didn't say to simplify the fraction at the end. They only said to express the answer in simplest radical form. However, if you're looking at this and saying, wait, this doesn't look as nice, well, what you could do is you could take this. So I'm just going to point out that this is extra, but an extra step, which you don't get extra credit for. So it might just be worth stopping here, but you take your answer, and what you could do is you could divide the numerator and denominator by 2. Or you could think of it as multiplying the numerator and denominator by a half. So, whichever way you want to think about it, but let's say we're multiplying top and bottom by a half. For the numerator, we would have x equals, and we distribute the half. So 1/2 times -2 is -1. And then we have plus or minus. If we do 2 times a half, that's equal to 1. So we just get 1 square root 7 over 12 times a half is equal to 6. So this is, once again, extra. You do not get extra credit for this, but this is a simpler form of the original answer. Question 33, the table below shows the price of a new cell phone and the length of time in months since its release. So we have this table here. We have time since release in months X, and then the price in dollars is represented by Y. And the first thing we have to do is state the linear regression equation for this set of data, and we're going to round all values to the nearest hundredth. So for this one, we're going to press Stats, Edit, and we're going to go and enter the values in the table here. So for L1, we'll put the X values. We have 0, 3, 6, 9, and then 12. And for the Y values, we're going to throw those in L2. We have 1200. Then we have 1150, 1100, 1000, and then 920. Okay, we type this in, and now we press Stats, Calculate Linear Regression is option 4. Now, before I do that, I'm going to press Mode, and I'm going to turn the Stats Diagnostics on. And I'm doing this because later in the question, they want the correlation coefficient. So if I do this now, I'll be able to get that information all at once. So I'll press Stats, and then Calculate Linear Regression is option 4, and I just press Enter all the way through. So we're going to state the equation, and we have to round all values to the nearest hundredth. So here, if we look, our a value here, so we have y equals ax plus b, but our a value, we're rounding to the nearest hundredth. We look at the hundredths place is a 6, to the right is a 6, so this would round to -23.67. Since we have a 6, which is 5 or higher, we're going to round up from 66 to 67. And then for the b value here, we have an even 1216. So we have 1216, and now we have to actually write the equation. So we're going to plug in for a and b. We're going to have y equals -23.67x, and then plus 1216. So here is our linear regression equation. For the next part, we have to state the correlation coefficient for this data set to the nearest hundredth. So we look here at the R value and notice that in the hundredths place, we have an 8. To the right is a 9. So we're going to round this. We're going to have R equals negative 0.99. Okay, so we're rounding up because a 9 is 5 or higher. So we're rounding from 98 up to 99. So this is our correlation coefficient. So now for the last part, we have to state what the correlation coefficient indicates about the linear fit of the data. Well, for correlation coefficients, the thing to know is that when your correlation coefficient is close to -1 or +1, your correlation coefficient is very strong. Okay, so this would make it a very strong correlation. All right, the closer we are to 1 or -1. As we move closer to 0, the correlation coefficient gets weaker. And if we make it to 0, then that means no correlation. So that's the space we're looking at here. We're between -1 and +1. So the fact that we got R equals negative 0.99, this is a very, very, very strong correlation coefficient. So all we have to say for this last part is that the correlation coefficient is strong, which means that our linear regression equation is an excellent fit for the data. Now, one thing I want to point out, if you've never seen this notation before, the 3 dots in math mean therefore. So I'm just mentioning here that therefore our linear regression equation from the first part is a very good fit for the data. Question 34, solve the following system of equations algebraically for all values of x and y. So for this system of equations, the first thing that jumps out at me is the second equation is not solved for y. So first I want to solve this equation for y, and then we could set these two equations equal to each other. So to solve for y, we want to get rid of that minus 2x, and the opposite of minus 2x is plus 2x. So we could add 2x to both sides. And now on the left side, negative 2x plus 2x cancels out, and we'll have y equals, so these terms cancel, and then we have 2x and then minus 6. So here's our second equation, but solved nicely, so that now we could set this equation here. We could set this one equal to the first equation. So now let's go ahead and do that. So we're going to have x squared plus 9x plus 4, and we're setting that equal to 2x minus 6. Okay, because when you're looking for a solution to a system of equations, what you're looking for is the points that they have in common, their points of intersection. So that's why we're going to be setting these equal to each other, because we want to see when do they match up. So for this type of equation, we want to move everything to the left side. We have a quadratic equation. We want 0 on the right side. So we could go minus 2x on both sides. And I'll just make that a little bit neater. So we have minus 2x. And also what we could do is we could do plus 6 to both sides as well. So in algebra, you are allowed to do 2 steps at once. So see 2x minus 2x cancels, and negative 6 plus 6 cancels out. And now you've got x squared. 9 minus 2 gives us 7, and then we have an x tagging along here. We're just combining like terms. And then 4 plus 6 is 10. So now from here, what we do is we factor this. And this part, we could solve this using the quadratic formula, but if my quadratic is factorable, I always prefer to factor over using the quadratic formula because it's much faster. So if you're factoring and you have a quadratic equation where you have a 1 in front of the x squared, you have an x term and a constant equals 0. What you do is you look for two numbers that have a sum equal to the coefficient of x, the b value, and you look for the two numbers. They also have to have a product equal to the number at the end. So we write our x's like this in parentheses, and then we'll just make that last one a little bit neater. And this is all equal to 0. But now let's think about it. Two numbers that will add up to 7 and multiply to 10. That would be positive 5 and positive 2. And if we just want to do a quick check, 5 plus 2 is 7, and 5 times 2 is 10. And now from this step, we're going to use the zero product property. When we have the product of two factors equals 0, that means that one of the factors has to equal 0. So we could either have x plus 5 is equal to 0, or we could have the second factor, x plus 2, is equal to 0. So this is showing us both possibilities. And now the first factor we could solve by subtracting 5 on both sides. And we have 5 minus 5 cancels, and we get x equals negative 5. And one thing to point out, when you have factors like this, just notice that the factors and the roots have opposite relationships. So when I have x plus 5 times something else equals 0, I know the root is just the opposite of what's inside the factor. So that's where we get to x equals -5. And now for the second factor, we're going to have x equals -2. But now if we stop here, this is very sad to stop here. There's more to do. The question said to solve algebraically for all values of x and y. So what we do from this step is we plug in the x values we found into one of the equations to solve for the corresponding y value. Okay, so let's just do that now. So we could say over here, when x equals -5, y equals, and I could plug in x equals -5 to any one of the equations, but I'll plug it into this one because this one already says y equals. So we have 2 times -5 and then -6. So this gives us y equals 2 times -5 is -10, and then -6 gives us -16. But what we should do at this step is we should write our answer as a point x comma y. So now I'm going to say one of the solutions here is -5, -16. So now we'll find the other point. So we have when x is equal to -2, y is equal to, so we're using 2x minus 6 again, but now we're going to have 2 times -2 minus 6, which gives us y equals 2 times -2 is -4, and we have -4 minus 6 is -10. Okay, so we have the point when x is -2, the corresponding y value is -10. So now off to the side here, I'm just going to write out our solutions. So the solutions are, I'm going to just write them both here nicely. We have -5, -16, and we've got -2, -10. So now we're moving on to part 4, the final boss. There's one question here, and the question is worth 6 credits. Question 35, Sarah earns $6 per hour babysitting and $12 per hour tutoring. Her goal is to earn at least $120 per week. Sarah is allowed to work a maximum of 14 hours per week doing both jobs. If X represents the number of hours Sarah babysits and Y represents the number of hours she tutors, write a system of inequalities that could model this situation. So for a question like this, I spend a lot of time thinking about how the variables relate to each other. There's a great quote by Abraham Lincoln. He said, if you give me 6 hours to chop down a tree, I will spend 4 hours sharpening the axe. So that's what's going on in this question. You really have to spend a lot of time thinking about how does this stuff connect. So here we're told that Sarah earns $6 per hour babysitting, and X represents the number of hours that Sarah babysits. So to combine these two, we would say 6 times X is how much money Sarah earns babysitting for X hours, because this is the rate she is paid per hour to babysit. And then the next piece of information to look at is Sarah earns $12 per hour tutoring, and she tutors for Y hours. So next we could say plus 12 times Y. So this is talking about money earned. Okay, so this over here is money earned. And let's think about, she said her goal is to earn at least $120 per week. So that means she needs to earn greater than or equal to $120. If we put a less than here, that wouldn't make sense because her money earned would be less than 120. She wants to earn at least 120, which means greater than or equal to. So that's why I really take my time thinking about this before I actually write something down. And then next, we're told that Sarah is allowed to work a maximum of 14 hours per week doing both jobs. So X and Y represent the number of hours that Sarah is working. So if we add her hours spent babysitting plus her hours spent tutoring, she's allowed to work a maximum of 14 hours per week. So she has to work less than or equal to 14 hours per week. She can't go over that amount, but she can work 14 hours. So this is the system we're going to write down. We're going to say 6x plus 12y is greater than or equal to 120. And then we have x plus y is less than or equal to 14. For the next part, we have on the set of axes below, graph the system of inequalities that you wrote. So for this part, I want to make use of the equation y equals mx plus b. We are dealing with inequalities here, but the concept is exactly the same. When we have y equals mx plus b, the m value is the slope and b is the y-intercept. So we're going to use that idea for this question. We're going to solve each inequality for y so that we could then graph it on the set of axes below. So let's start with the first inequality. We have 6x, and then plus 12y is greater than or equal to 120. And from here to solve for y, we could do minus 6x on both sides. Okay, so we have this on both sides. These terms cancel, and then we have 12y is greater than or equal to negative 6x plus 120. And then from here, we divide everything by 12. So we divide each term by 12, and we'll have y is greater than or equal to negative 6 over 12 reduces to negative 1/2. And then we have our x, and then plus 120 divided by 12 is 10. So this is the first inequality solved for y. And the second one is much easier to work with. We have x plus y is less than or equal to 14. So for this one, we could just do minus x on both sides. And then from here, we're going to have y is less than or equal to negative x plus 14. So now we could just go ahead and graph both of these. But let's start off here with the first one. So we have y is greater than or equal to negative 1/2 x plus 10. So we go to 10 on the y-axis. That's our y-intercept. And then remember, the slope tells you the rise over run. Okay, so we're going to rise negative 1 and run 2. So we're going down 1 over 2. And we could just repeat this the whole way. And for this one here, I'm just going to go to the end of the graph. So we're just going to keep going. And then once we get to the end of the graph, we could just connect these points with a straight line. So for this, I would use a ruler. If you don't have a ruler, use a student ID, something that can make nice straight lines. And we have y is greater than or equal to negative 1/2 x plus 10. So for this one, we're going to shade above like this. Okay, so we just shade above. And now we could graph the next one. So the next one I'll do in blue, we have y is less than or equal to negative x plus 14. So our y-intercept this time is 14, and our slope is negative 1. So we're going to rise. So for this part, when I hear slope is negative 1, I think of this as negative 1 over 1. So we're going down 1 to the right 1. Okay, so we just keep repeating this, down 1 to the right 1, and we do this the whole way until we get to the bottom. Now, if you had to check your answer to this, one thing you could do to see how reasonable your graph is you could look at the intercepts. So notice here that when x equals 20, y is equal to 0. And you could even see if I do 6 times 20, I get 120. And then I get plus 12 times 0 is 0. So what we have is I'll just write it off to the side. 6 times 20 plus 12 times 0 is greater than or equal to 120. This gives us exactly 120 is greater than or equal to 120. So I like to just plug in a random point just to make sure that it's satisfying the inequality. And that way I know that I didn't graph wrong. So now I'll just connect these points here. So we have this point here, going to connect all the way to the bottom. And what we're going to do next, we have y is less than or equal to negative x plus 14. So for this one, we're shading under. Okay, so we go under like this, and I'm going to shade all the way across. And now before we move on, a few things I want to point out. We have to label at least one of the inequalities, but I'll go ahead and label both. So the green one here, we could use the new inequality, the one that we did the algebra and solved for y, or we could use the original. So we could say that this is the 6x plus 12y is greater than or equal to 120. And then for the one in blue, this was y is less than or equal to negative x plus 14, but originally this was x plus y. So I'm just going to write x plus y is less than or equal to 14. But another thing I want to point out here is that these two inequalities overlap in this space over here. So I'm just going to highlight this space. This is where the blue and the green meet, because when we have to identify a solution for the last part, this is the space we want to look at. And now for the last part, we have to state a combination of hours babysitting and tutoring that would satisfy this situation, and we have to justify our answer. So for this one, I pointed out before that we were interested in the overlap of the regions here. And we could pick a point here in this space, and that would be a combination of hours babysitting and tutoring that would satisfy the situation. So let's say I pick this point over here. This is nice and in the middle of that space. And I'm just going to label these points on the x-axis. So we have 1, 2, then we have 3, 4, 5 is already labeled. And then here we're at 10. This does go up to 11, and then 12, 13, and then over here we have 14. But we are going at this space here where x is equal to 2 and y is equal to 10. So I could say the point is 2, 10, all right? And this is our x, and this is our y. And then we have to justify our answer. So for this one, what we could do is we could plug these x and y values right into the original inequalities and show that they satisfy both inequalities. So now let's plug this point into both inequalities. And it's very important that we check that it satisfies both. So now we have 6 times x equals 2 plus 12 times y is equal to 10 is greater than or equal to 120. And now we work this out. We have 12 plus 120 is greater than or equal to 120. And that gives us 132 is greater than or equal to 120. And this is a true statement. And now next we plug into the second inequality. So we have x equals 2 plus y equals 10. And this should be less than or equal to 14. And this gives us 12 is less than or equal to 14, which checks out. So since the point satisfies both inequalities, this combination here does work.